Hello and welcome to another video. Today we're going to be working on group the people given the group size they belong to. So this problem has a little tricky wording, but there are n people that are split into some unknown number of groups. Each person is labeled with a unique ID from 0 to n-1. So essentially if you have like 5 people, they will be 0 to 4, kind of like indices in an array. And you're given an integer array group sizes, where group size I is the size of the group that person I is in. For example, if group size is 1 equals 3, then person 1 must be in a group of size 3. Return a list of groups such that each person I is in a group sizes, and each person should appear in exactly one group, and every person must be in a group. If there is multiple answers, return any of them. It is guaranteed the at least one valid solution. And this, it's guaranteed that there will be at least one valid solution, makes this problem a lot easier. And also, you don't need to return every single possible combination, which makes this problem a lot easier. Like if it said like, return every possible combination, this would definitely be a lot harder. But in this example, so they show for all of these indices, group sizes is 3, 3, 3, 3, 3, 1, 3. And so one possible solution is, so for these sizes, let's just draw these and make them a little bigger and kind of explain them a little bit better. 3, 3, 3. 3, 3, 1, 3. So here they don't really tell you, but n equals 6. Actually, n equals 7. So there's 7 people, and their IDs are 0, 1, 2, 3, 4, 5, 6. So basically what it's saying is everyone but number 5 should be in a group of 3, and then number 5 should be in a group of 1. So one possible solution is 5 has to be by himself. But then for everyone else, they just have to be in a group of 3. So any combination works, like 0, 1, 2, 3, 4, 6 works, or any one of these can be interchanged as long as both of these groups are a group of 3. So the tricky thing about this problem, the thing that makes it really easy, let's actually look at the second example as well. So in this group sizes, it's group of 2, group of 1, group of 3, 3, 3, and 2. And so you can see in this group of 3, 3, 3, these 3 people. So let's actually draw this as well. So 2, 1, 3, 3, 3, 2. And the indices are once again 0, 1, 2, 3, 4, 5. So you can see that 2, 3, and 4 have to be in a group of 3. So they have to be in the same group because there is no other group of 3. So 2, 3, 4 have to be in the same group. And then 0 and 5 have to be in the same group because they have to be in a group of 2, and there are no other groups of 2. And 1 has to be in a group of 1. And obviously the order doesn't matter here. But essentially, the thing that makes this problem easy, or quite easy once you get like the trick, is if someone has to be in a group of 3, every person in that group has to be in a group of 3, right? So if like this person has to be in a group of 3, the group he's in, every other person also has to be in a group of 3, right? Like, that has to be the case. So we can simply do like I don't know if it's like greedy, but essentially we can just put people in the group that they want to be in, and then once that group fills out, we just put it in the result. So let's kind of go through how that works. So we're going to have this result array, and essentially what we need to do is we need to somehow figure out or store the group that each person needs to be in. So let's actually copy this down here because this is the example we're going to be using. So what we need to do is we need to put people like you need to put people that are in the same size group in the same group. It doesn't matter like which ones, like I said for the 0, 1, 2, 3, 4, 6. It doesn't matter like which ones you put in the same group, but you have to have them in the same group. You can't put person 5 in a group of 3, right? So essentially, you can write this down. If a group has size 3, then the only people that can be put into it have to have group size 3, and so on, right? So if this person needs to be in a size 3 group, he needs to be put in the same group as other people with the same number. So you need to put in people with the same number in the same groups. Now there's different combinations, but you can't put someone in to a group that has number 3 and then another person with number 2, because that wouldn't work, right? if I need to be in a group of 3 and you need to be in a group of 2, we can't be in the same group. It doesn't work. I have to be in a group with another person that also needs to be in a group of 3. Once you realize that, it makes it really easy. So essentially all we need to do is we need to have a hash map. So we can just call that groups or whatever we want here. And we are just going to put people in a group of some size, and we need to keep track of like that group of some size. So essentially what's going to happen is, like, let's say we're at this first person, index 0, and we need to say like, okay, this person needs to be in a group of size 3. So is 3 in our hash map? Well, right now, no, it's empty. So we're just going to make a key 3, and we're just going to make a new group, a new array, and we're going to put that index into the hash map. And then we can check, okay, is our current group of size 3? If it is, let's just get rid of that group out of the hash map and put it into the result. So essentially, every time a group fills up, we can put it into the result, and then we can get rid of the group. So what's that going to look like? Well, let's go through this example to kind of show you, and then we can go through the second example as well. So for person 0, we're going to put it in a group of 3, and we're going to check, is this group size 3? No, it's not. Okay, for person 1, we're going to put it in a group of 3. We're going to check, does a group of 3 exist? Yes, it does. There is a 3. So we're going to put person 1 in here. Okay, what about for person 2? Does a group of 3 exist? Yes. Let's put person 2 in here. And now notice that this group size is the key. So whatever key we look for is the group size. Every time we put in a value, we need to check, is the group size big enough to be the group that we want? And yes, it is. So we have a group of 3. So now what we're going to do is we're going to put 0, 1, 2 into the result, and we are essentially going to delete this group out of the hash map because now we've already put it into the result, so this group no longer exists. We need to put people into a new group. So now we will go to this person. We say, okay, he needs to be in a group of 3. Does a group of 3 exist? No. Let's make a group of 3, and let's add that person in. And then for this person, he needs to be in a group of 3. So does a group of 3 exist? Yes. So let's add that person in. But it's still not long enough to put into our result. Then for 5, he needs to be put into a group of 1. Does a group of 1 exist? No. So let's make a group 1. Let's add 5, and we need to check, is that group length big enough to be the key? Yes, it is. So this group is essentially complete. So now we will put 5 over here, and that group has been used, so we can get rid of this. So essentially, every key will only have one group, and once the group is used up, we will just get rid of that out of the hash map. And now finally, for the last one, we say, okay, 6 needs to be in a group of 3. Okay, we have a group of 3, let's add in 6, and now this group is complete. It's length 3, so now we will put in 3, 4, 6. So it's as easy as that. Once you realize you can just put people greedily into the same group as other people that want to be in the same group size, and every time you have a completed group, you just put that into the result. So that's that example. Let's go through this second example here. So this 2, 1, 3, 3, 3, 2 example. Okay, so we're going to go through that. So 2, 1, 3, 3, 3, 2. And you can see all of these, there's going to be like so for example, for everyone in a group of 3, in order for this to be a valid thing to have a solution, there need to be, the number of people that have 3 in their group needs to be a multiple of 3, right? Like if there were 2 people that need to be in a group of 3, that wouldn't be possible. Same thing for 2. The number of people that are in a group of 2 is a multiple of 2, and for 1 is a multiple of 1. Okay, so let's do the same thing. So we're going to have this result, and we are going to have indices here. But yeah, it's literally as simple as that. You just put people into the same group that they need to be in, and then once that group is full, you put it into the result. So let's go through this. Let's have our group here. Okay, so we start here. We say, okay, so we need to put index 0 into a group of 2. Do we have a group of 2? No, we don't. So let's create one, and let's put 0 into it. Okay, now we need to put index 1 into a group of 1. Do we have a group of 1? No, we don't. So let's put 1 into it. And now that group is the length we wanted. So now we're safe to put that into the result. So we can put this into the result and get rid of the value because we've just used up that group. Okay, now let's go over here. So index 2 needs to be in a group of 3. So let's make a group of 3. Put index 2 into it. It's not big enough yet, so we'll keep going. Index 3 needs to be in a group of 3. It's there. Let's add them in. Index 4 needs to be in a group of 3. It's there. Let's add them in. And now finally, this group is big enough to be the key that we wanted. So now we're going to put that into the result. So 2, 3, 4. get rid of that group. And then finally, we looked at these now. Index 5 needs to be in a group of 2. There is a group of 2. And now this group is big enough to be of the size of the key. So then we can put 0 and 5 in, and that is our solution. And obviously, here there is only one solution. It just depends which order you have it, because the people in a group of 2 have to be in the same group, and then the people in this group have to be in the same group. There aren't multiple groups of 3. So here there's only one solution. It just depends on the order that you put your stuff in. So it'll be 1, 2, 3, 4, 0, 5, just like it showed, and the order doesn't matter. And that's pretty much it. So it's literally just a greedy solution where you just keep putting people into the group size they want to be in, and once that group size is achieved, you just put that into the result and you get rid of it from the dictionary. So let's actually code that up now. So we are going to make a result, and we are going to make groups. We're going to make a default dict list. You can honestly make a normal dictionary too. So for IV, index value in enumerate group sizes. And if we want to make like better variable names, we can say like for ID, and this can be like group size or something. That would work too. So it's going to be groups, and then which one do we need to add it to? So it needs to be, the key is going to be the group size that person needs, right? So if that person needs to be in a group of 3, we need to add it to key 3. So we're going to append I. And the nice thing about using a default dict is if this value doesn't exist, it'll just be an empty list. So you'll just create a new empty list, and it'll just append that ID. So it should be ID. I think actually ID is like a special Python thing. So maybe we can just use I here instead. Okay. So now that we appended it, we need to check, is that group long enough to match what we want? So if length of groups group size equals the value we want. So you can either check for group size, or yeah, it's basically going to be group size, right? So like if I put ID 0 into a group size of 3, then I need to check, is my actual list, or did it reach length 3 or not? And if it did, then we'll put that into the result. So if it is true, then we can append it. So we can append group size. And finally, when we append it, we need to actually delete it from our hash map, right? Like we've used it, we don't want to append to it, we want to make new ones. So this should be group size. So we delete it, and then like I said, because we are using a default dict, this will just auto make a new list if that key isn't in there. So it's like, just saves us a little bit of code. And then finally, we need to return the result. And that should be fine. So this is kind of all over the place, actually, and all solutions are pretty close. Like I think when I ran it and it was 16.4 megabytes of memory, that was like in the 90th percentile or something. So if I just run it a bunch of times, it's kind of all over the place. So I would say that pretty much everyone has the same space complexity here, and the time is as efficient as it gets as well. So I wouldn't really worry too much about like this kind of thing or whatever. It's pretty efficient and everyone's around the same. Okay, so now let's think of the time and space complexity for this solution. So if the result doesn't count, we do need to make this groups dictionary, right? And so for the groups dictionary, like how big is it essentially? Like what's the worst case scenario? Well, the worst case scenario, if you think about it, we will put roughly every element in the list into a group. Obviously not quite there, but roughly that, right? So worst case scenario, our dictionary, or actually, I guess this is for the time. So for the time, we are essentially, this is big O of n, because we're essentially adding the element into the right group, and then we are just simply appending the group. So technically, it's going to be like a little bit more than big O of n, because you are appending to a list, and then you are appending a list, but it's going to be something like big O of 2n or something, which still simplifies down to big O of n. And then for the space, like I said, so we have this groups, and worst case scenario, groups will contain more than half of the actual unique IDs, essentially. And so that's going to make it O of n as well, because like let's say someone wants to be, like you have something like this, right, as like a worst case scenario. Let's say everyone wants to be in the same size group, and there's 5 people. Well, now you will put 4 people into your group list, so that's most of your list, right? So essentially, if the group, worst case scenario, everyone wants to be in the same size group, of your whole list. So let's say this is length, whatever the biggest number is here, like 500. Everyone wants to be in a 500 person group. You will essentially keep appending people to your list. And then only once you get to the very last person will you actually remove them all. So that's basically O of n, because you're essentially appending every single number. So worst case scenario, it's O of n. You can't append more than n people into your list. So that's going to be worst case scenario. And then time is O of n as well. But yeah, like I said, it's as efficient as it gets for this problem. And yeah, solutions all over the place. So like I said, yeah, I think that's going to be it for this problem. And I do think once you realize it's greedy, like trick kind of, I don't even know if it's a trick. Like I definitely thought it would be a lot more complicated until I thought about like, oh, hey, I can just put everyone that wants to be in the same group. And once that fills up, I'll just make a new group. Like once you realize that, it definitely makes the problem, like the coding of it, really, really easy. But I guess it's kind of hard to realize the trick. So that's going to be it for this problem. Hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I'll see you in the next one. Thanks for watching.